Hello and welcome to Computer Tech and More. Today we're going to be talking about the Arctic P14 computer fan, and this is part of my sort of redone series. Okay, first up is comparison. So we have the original testing methodology over here on the right side, and we have the new testing methodology on the left side called the Arctic P14. And originally it ranked 14th with an RPM of 600 and a noise normalized air velocity of 0.6 meters per second. I did say it was ranked 14th. It is now ranked 12th, so it actually improved, relatively speaking, in performance compared to the other fans. Let's move on to the next one. And when we're looking at things at 100% RPM, it's ranked exactly the same place because nothing has changed. All right, let's move on. It's ranked 5th, by the way. When we're looking at CFM, so that's putting the fan through the tube, blowing the air down the tube, and seeing how it does, it was originally ranked 15th. And it's now ranked 13th, and you can see the CFM values listed right there, as well as the RPM that it achieved while doing the noise normalized testing. At 100%, it's once again in the same spot, and it's ranked 13th. Moving on to the 6-inch noise normalized position. So that is in my case simulation test, the 6-inch mark. So that's the microphone or the anemometer 6 inches away from the fan. How well does it perform? Well, it originally ranked 14th, and it still ranks 14th when we look at things at the 11-inch mark. So again, I took it at 6, 9, 11, and 14.5. So the 11-inch mark is sort of a third step. It was originally ranked 13th and is now ranked 10th. So it gained a little bit of performance, relatively speaking, to the other fans, meaning it produces a little bit less noise or pushes more air for the same noise value compared to other fans. When looking at the value proposition compared to the original versus the new, originally it was ranked 4th, now it's ranked 3rd. So it's gone up in position by a little bit, and the value rank is listed right there. Next, we have the value proposition at the 11-inch mark. Originally it was ranked 3rd, now it's ranked 1st. So that is an truly excellent result going on for the P14. When we look at its value proposition of air through a cooler, originally it was ranked 5th, now it's ranked 2nd. All right, now that we've seen how it sort of ranks up compared to the old testing versus new testing, let's actually explore that data. So the first graph here is from my case simulation test. The case simulation has a couple different ways of looking at it. The first way is, what size case are you actually purchasing? Are you purchasing a small form factor that still is a front-to-back airflow, so a more open type small form factor case, or a compact tower, so that would be indicative of a 9-inch size, the length, or a mid-tower case, which is the 11-inch mark, or a truly large full tower case, something like the 14.5. And the 14.5 would be something like the Corsair, or not Corsair, would be something like the Fractal Design Torrent. The 11-inch would be like the Corsair 550D or a Messerfy 2C, something like that. I don't have specifics for 9 or 6-inch mark, but it gives you some idea. I took measurements of a bunch of different cases to online listings and figured out roughly what these measurements should be. How does it compare against my control fan? My control fan is 3 parts A12X25 to 1 part A14, and you'd be looking for the fan to be outperforming it here in the top right. So in the bottom axis you have distance, in the top you have, or vertical axis, you have air speed, and you can see that the P14 is okay. It doesn't push as much air as my control fan early on, but it doesn't lose as much air velocity as time goes on. It actually narrows the results pretty substantially by the 14.5-inch mark, but it is underperforming at noise normalized values. At 100%, it actually outperforms my control fan. So the control fan has that nice deep steady drop, while the P14 actually doesn't drop off quite as steeply. So that is a very impressive result. It leads it to be a pretty good choice for a case fan. All right, so now how does it compare against a bunch of other fans, respectively, basically? Well, I took a sampling of fans that I felt were good indicators of poor performing fans and as well as good performing fans, and I included one 120mm size fan, the A12X25, because it's actually fairly representative of what you would want from a good 120mm fan. But when I do the 120mm roundups, you'll see more variation there. But anyways, onto this data. So right here at the top, we see the Silent Wings 4 Pro. We actually have the A12X25. It is doing very, very well. The Arctic P14 actually is one of the worst performers at the 6-inch mark, but then it just doesn't lose much airspeed as time goes on. Meaning that by the time you hit 14.5 inches, the end of a big case that's where the air would hit the CPU fan, right? It's third out of the fans in this selection, but it's actually a pretty good result, almost equal to the A12X25. So that's not half bad. When we take a look things at 100% PWM fan signaling, so this is letting the fans blow as much air as they can, we see the RPM and the noise level. The Arctic is actually, well, it's a little on the noisy side for its 1,765 RPM, but it's honestly not that bad of a result. It is moving less air than top performers like the A14 3000, and obviously same as the Silent Wings Pro 4. It's not quite in that category, but it's really holding up really well. But it's not a bad choice for a front fan in your case. Next up, we're taking a look at the 9-inch mark, so the 9-inch spacing, so that's right here. And that's airspeed versus decibels. The 9-inch mark is sort of where the fans that blow air off to the sides don't perform really well, but they haven't completely dropped off, where it's really hard to get any sort of measurement at all. And where basically the good fans that create concentrated airflow are still really performing quite well. So it's this sort of middle ground between the two. So right here, highlighted in the most bold line, is the Arctic P14. You'll see this one little joggle right here. And this is where I hit a harmonic frequency. It's either in the fan or my whole testing setup, but either way, it's a harmonic frequency. So whether or not you find it, I cannot verify for you, but that is what I found with my current testing setup. And so the fan got particularly noisy at this airspeed and RPM before coming back to normal and actually having pretty good results. So it actually starts off kind of middle of the road and then kind of continues that path all the way along. The difference is it doesn't have the top end RPMs that some of the other fans do, like the Silent Wings 4 Pro and the NFA 14 IPC. But it's actually doing really well overall. Next up, we have airspeed performance through my CPU air cooler, and that is the Noctua U12A. And on the left side here, we have RPM, horizontal, to airspeed, vertical. So this is a blade efficiency. It is how much air can this particular blade design push for a given RPM. That is my personal way of looking at it. So if you're into basic aerodynamic design, this is what you'd be specifically looking at. And it's just pure efficiency for how good it is at pushing air. On the right graph here, we have airspeed vertical and noise horizontal. So this is how quiet is the fan at pushing that amount of air. So it's a noise efficiency graph. And comparing these two, you get all sorts of good information from it. But in both of them, better fans are going to be sitting into the top left, worse fans in the bottom right, and you really want fans to be either outperforming or closely matching my control fan, where the control fan is what I consider to be a quite good fan, but not quite, actually no, I would consider it a very good fan. So basically getting over it, you get an A+, match it, you get an A, you get under it, depending on how close under it you are, you're like B to F. So as we can see from the graphs, in the blade efficiency side, so RPM, the P14 is actually outperforming my control fan. So that is a very, very good result. In terms of noise efficiency, it is underperforming. I give it in the B, maybe B+ type category, except for this harmonic frequency. It's just a little unfortunate that we hit it right there, and we can see that it happens at about this 1,000 RPM mark. But how does it compare against other fans? Well, this is a full listing of all 140 millimeter size fans. Because I don't have as many 140s tested thus far, I can fit them all on one graph, so this is exactly how it ranks. It's not a bad result, but it is towards the bottom. Next, we're taking a look at things at 100% PWM fan signaling, and we have my same wattage calculation here. If you're consider joining my Patreon page and helping me out, it'll go directly into buying better equipment, better microphones for noise testing, to build myself a little noise chamber. I actually have an idea on how I would make it. But I can't do it without help from viewers like you, so I appreciate if you join my Patreon page. Anyways, back to the data. So here we have the rankings at 100% RPM, and we can see that the P14 is actually one of the top performers here, especially for its given RPM. It's outperforming the Mobius 140p, and the 140p is spinning a good 200 RPM faster for the same noise level. So the 140p is actually quite noise efficient for its RPM, but not as performant for the same RPM. So it's a less efficient blade design. So that's kind of a very interesting result. And you can basically look at these and go, well, which fan gives me the most performance for the least amount of noise? And you can see as we cross into the threshold of over 2000 RPM, many of the fans start getting quite a bit noisier, like the Tough Fan 14, the Silent Wings 4 Pro, 140, the Iceberg Thermal. They all start getting pretty noisy. So it's really an impressive result for the P14 here. And next up, we have cooler air speed, so airspeed going through the cooler, versus decibels. Just a simple graph with a small selection of fans so that it makes sense. The P14, again, we have that one bit of odd noise right there, as opposed to just being nice tracking. But overall, it's not a bad result. It actually is ranked towards the top here. Next up, we have my CFM graphs. These are included because many other reviewers who don't understand fans do CFM, and I just wanted to include it to cover all of my bases because a lot of people think in CFM. But CFM is just cubic feet per minute, and you could convert any of my other calculations to cubic feet per minute if you really wanted to, but there's not much reason to. So in my version of CFM testing, I put the fan up against a tube of appropriate size for the fan. So 120s and 140s cannot be directly related because I use a different size testing apparatus. But you're basically putting the fan up against a tube and letting the air just blow down the tube. It gives no room for the air to spread out and effectively doesn't slow down, doesn't spread out. The air just all moves in one direction down the tube, which is why I think it's not a particularly good test for how does this fan perform in my computer. But we have RPM versus CFM and noise versus CFM. These two graphs are fundamentally similar to my graphs for the CPU cooler, where better fans are sitting in the top right, top left, worse fans are sitting in the bottom right. When we take a look at things noise normalized versus all the other fans I've tested, it does have a tendency to be towards the bottom of the graphs. But it's overall not a terrible result, but it is kind of below my control and below a lot of other fans for that noise value. When we take a look at things at 100% PWM fan signaling, it is actually still towards the bottom of the graphs. Its noise value isn't that bad, but it's just not pushing as much air as many of the other fans. And last but not least is CFM versus the decibels. And right here we see the P14 being basically towards the bottom of the performance. These little joggles you see here are where I hit a harmonic frequency within the fan or the fan related to my testing apparatus. Alright, now we're into the value proposition. So how does the P14 rank? Well, overall compared to many of the other 140mm fans, it's actually doing really quite well. But when we take a look at the 120s, we see that there are many other fans that just have much better value for their performance, something like the TLG12. At 100% PWM fan signaling, we see a similar result, except it actually gained in performance. It does, relatively speaking, much better. And in this value proposition, it's airspeed per dollar. P14, again, it's a good result, but it just doesn't quite match the value of some of the 120 millimeter class fans. Moving on to that 11-inch mark, we can see that the P14 is actually the top performing fan here for the 140 millimeter class, but it still can't hold a candle to something like the TLG12. When we're taking a look at things at 100% PWM signaling, it has gained a lot of performance. It is, I call it a top performer, but it still is lagging behind a lot of the top performance in terms of value proposition in the 120 millimeter class. So you have to weigh what you want here. When we take a look at its performance through my CPU air cooler, well, noise normalized, it is one of the top fans for noise normalized results, but once again, it's the same sort of story where it can't hold up quite as well against some of the top performance in the 120 millimeter class fans. At 100%, it is not first, but it is in second ranked, but it's the same story that I just iterated a couple times now. All right, and as always, I like to show off my test data. Here's the test data for the Arctic P14. And if you would like to use this data for your own purposes, you may go ahead and do so. However, if you do use it in any sort of publication or video, I require that you do reference me, since I'm the one who generated this data. It takes me approximately an hour and a half to just generate the data, and then it takes many more hours to update graphs, make the presentation, write my script, and then make the video. So if you do use it, please reference me. Thank you very much. And I do want to say thank you for watching, and I hope to see you next time here on Computer Tech and More. And please check out my Patreon page. Viewers like you will really help make this channel more possible.